In the previous videos, we looked at the capacity planning process. So we talked about how we would need to forecast demand, and then we turn that forecasted demand into a capacity requirement. We then measured where we currently stand, and then we need to decide how we're going to bridge that gap. And so in previous videos, we looked at some of the considerations we need to make when we're looking at bridging that gap. So now I want to focus on the last part, which is how do you choose an alternative and implement it? And so to help us with choosing an alternative, we're going to look at what is called a break-even analysis. So break-even analysis is used to determine whether you should outsource part of your production or whether you should make it in-house. So if you are manufacturing a truck, should you be making the chassis or should you outsource that to another company and then just bring that completed piece in to add to the truck as you are doing assembly? We can also use this method to determine if between two different methods to make our product. So maybe we have two different production methods. One method uses one type of equipment and another one uses a different one. They might have different costs. So we need to be able to compare how much it will cost to use these different methods to determine which one is better. So we're going to look at an example of this. So we're going to look for what's called the break-even point, and the break-even point is the quantity of output at which total revenue and total cost are equal. We can actually find a formula for break-even. So we're just going to spend a moment and derive that formula. You just need to know what that formula is, but let's look at where it comes from. When we talk about break-even, what we mean is that your total revenue, the money you're bringing into your business, is equal to your total cost. So we're making no profit because the money we're bringing in is equal to the cost to make it. When we talk about total revenue, we're talking about the quantity that we are selling times our revenue per unit. Sometimes you see that as price, and we'll label this here with a capital R as revenue per unit. Our total cost then is our fixed cost plus a variable cost, and since it's a variable cost, it's going to be a function of the number we produce. Okay. So here we have R times Q equal to our fixed cost plus V times Q. Well, to find the break-even quantity, we need to be able to rearrange this formula and solve for the Q. So to do that, we need to put everything that has a Q on it on the same side. So since we're adding V times Q over here, we need to subtract it to make it go away. So we do the opposite. If you're adding, you subtract it to get it to the other side. So notice now that we have quantity all on one side, which means we can take the quantity out of both RQ and VQ, and we get Q times parentheses R minus V equals FC. So in other words, we can take the difference between the revenue per unit minus the variable cost per unit and multiply that times the quantity, and that will be equal to the fixed cost. So now we want to get quantity by itself. Well, notice that Q is multiplied times that revenue per unit minus the variable cost per unit. So we can then get rid of it by dividing by it. And so the break-even quantity is the fixed cost divided by the revenue per unit minus the variable cost per unit. So we're able to now use this formula to find the break-even quantity for a particular production method. So we can figure out at what quantity are we not making any profit, but we're also not losing any money. So let's look at an example. So let's suppose we have two different production methods. One uses machine A, one uses machine B. The fixed cost with machine A is more money. So the machine itself costs us more, $40,000. Machine B costs us $30,000. Now, when it comes to running the machine, machine A is cheaper, $10 per unit. Machine B costs us $12 per unit. Now, based on the quality that the machines produce, we can sell them for slightly different prices. So machine A, we can sell that at $15 per unit, and goods made by machine B, we can sell for $16 per unit. All right, so then we need to figure out what is the break-even point for machine A and machine B. So we want to find that quantity that we break even. Let's start with machine A. So we would take the fixed cost of $40,000 and divide by our revenue per unit, which is $15, minus the variable cost per unit, which is $10. So that gives us 40,000 divided by 5. And we put that into a calculator. And we find that the break-even quantity for machine A is 8,000 units. Well, what about machine B? So to find the break-even for machine B, we need to take 30,000, divide by 16 minus 12. So that's 30,000 divided by 4. Now put that into a calculator. And we find that's 7,500. So with machine B, we would break even at a lower quantity than machine A. Well, so what does this mean? This means if our forecasted demand was, say, 7,800, we would be better off going with machine B because machine B breaks even at 7,500 and machine A doesn't break even until we hit 8,000 units produced. So if the forecasted demand is somewhere between 7,500 and 8,000, we should go with machine B. But what if the forecasted demand is, say, 12,000 units? Okay? Then we need to figure out which machine would give us more profit. So instead of calculating just the break-even quantity, now we need to be able to calculate profit. And profit, we can label or symbolize profit with a pi symbol, is equal to that total revenue minus total cost. Remember, total revenue and total cost is what we use to derive break-even by assuming that profit was 0. So now we want to look at what's the level of profit for the two different machines at different quantities. And also we would like to look at, is there a quantity at which the two machines would give us the same profitability? So let's first look at what is the profit if our forecasted demand is 12,000 units. Well, if profit is total revenue minus total cost, then that's going to be our revenue times quantity minus, and make sure you put in brackets, the fixed cost plus that variable times quantity. Because it's a bracket here, that's telling you this negative that's in front of it goes to both the fixed cost and to the variable cost. So we need to take our revenue times our quantity minus the fixed cost minus the variable cost times quantity. So notice this negative here goes to everything that's in that parentheses. All right, so let's do that calculation. Well, revenue per unit for machine A is 15, and we're looking at a quantity of 12,000. Minus the fixed cost of 40,000, minus the variable cost of $10 a unit times the 12,000 units. Okay, so we could put that into a calculator and find out what we get. So that's 15 times 12,000 minus 40,000 minus 10 times 12,000. So what we find is the profit for machine A, if we're forecasting 12,000 units, our profit here is 20,000. Okay? Well, how does this compare to the profit of machine B for those forecasted 12,000 units. Well, it's the same formula, that total revenue minus total cost, so R times Q minus fixed cost plus variable times Q. Remember again to take that negative and put it in front of both, so we'll do R times Q minus the fixed cost minus the variable times quantity, which for this example is revenue of 16, quantity of 12,000, minus the fixed cost of 30,000, minus our variable cost of 12 times the 12,000 units. So we take our 16 times 12,000 minus 30,000 minus 12 times 12,000, and we find 18,000. So notice if the forecasted demand is 12,000 units, then using machine A gives us profit of 20 grand, and using machine B gives us profit of 18 grand. So in this case, if we have forecasted demand of 12,000 units, we would rather have machine A because it's more profitable. But the key thing here is that machine A is not necessarily always more profitable, right? We said that if the forecast demand was between 7,500 and 8,000, we'd rather go with machine B. So we can actually look at different ranges of forecast demand, which machine is better. And we're going to do that just momentarily in Excel. But first, let's look at this question here about what quantity will give us these two machines giving us the same level of profit. So if we want to find out which quantity gives the two machines the same profit, then we need to create an equation where the profit for machine A is equal to the profit for machine B. So remember, profit is total revenue minus total cost for both of them. And total revenue is revenue times quantity. And our total cost is the fixed cost plus the variable times the quantity. Okay, so that's true for both formulas. The difference between these two formulas, of course, is going to be the revenue per unit, the fixed cost, and the variable cost. Okay, so we're just going to make sure that that negative goes to both the fixed cost and the variable cost, R times Q minus fixed cost minus variable times quantity. All right, so now let's start putting numbers in. So we know the revenue per unit for machine A is 15. We're going to leave the Q's. They're a holding place for the number we're trying to find. And then the fixed cost for machine A was 40,000 minus, make sure you have that minus for that variable cost, minus $10 per unit times quantity. For machine B, the revenue per unit was 16. Okay, quantity is a placeholder. We're going to solve for Q later. Minus, and then we have the fixed cost of machine B, which is 30,000. And then minus, make sure you have the minus for that variable, $12 per unit times the quantity. Now, ultimately, we're going to solve for quantity, but we can simplify this formula pretty quick. Notice on the left, we have 15Q and a minus 10Q. Both of these contain a Q, so that means that we can combine them. So that means we can take 15Q minus 10Q, put that together, and then minus 40,000. On the right, notice that we have a 16Q and a 12Q, so we can put that together, and then we have minus 30,000. So since we have two numbers with a Q on one side of the equation, we can collapse it down. So 15Q minus 10Q is 5Q. And then we have our minus 40,000. And on the right, we have 16Q minus 12Q. Since they both have a Q in it, we can reduce that to 4Q minus 30,000. Now what we need to do is get all the Q's on one side and get everything else on the other. Okay? So notice that 5Q is bigger than 4Q, so let's subtract 4Q from both sides. And so we end up with Q minus 40,000 is equal to negative 30,000. Okay? Now we need to get Q by itself, so let's move the 40,000 over by adding 40,000 to both sides. And what we end up with is Q is equal to 10,000. So the quantity at which the profit from machine A and the profit from machine B are equal is at a quantity of 10,000. So you should be able to work through a problem like this and find where two different production methods would give you the same profitability. So it really goes down to how do you calculate a profit and then use Q as your placeholder, reduce it down, get Q onto one side, and solve for Q. Now let's take a look at this inside Excel so we can actually see at what forecasted demand levels which machines or which production methods are better. So we've already found that between 7,500 and 8,000, we'd rather go with B. We found that at 12,000 units, we would rather go with A. And we found that at 10,000, it doesn't matter which machine we go with because we're getting the same level of profit. So let's look at that in Excel. To do our break-even analysis for our capacity planning in Excel, we need to create a couple columns in Excel. So we need to look at quantity, and then we need to look at machine A and machine B. Let's just make this a little bit bigger so we can see it. All right, in this case, let's look at different quantities. Let's look at it in increments of 1,000. So 1,000, 2,000, and we can keep going all the way up. And let's go up to 25,000. Okay. Now, when we look at machine A and machine B, we want to look at profitability. So remember that if we want to find profit, it's going to be our total revenue minus our total cost. And remember that total revenue is going to be the revenue per unit times the quantity. And total cost is fixed cost plus our variable cost, and variable is a function of the quantity we produce. So when we go in and we want to calculate profit at these different quantity levels, we're going to need to create a formula for machine A and machine B that will be the formula for profit, and then we can just change the quantity within that formula. So to do that, we will first do total revenue. And remember, for machine A, revenue per unit was 15. And we're going to multiply it times the quantity. So we highlight the cell with the quantity in it for that. And then we're going to subtract, and this is going to be the fixed cost. So the fixed cost for machine A was 40,000. Okay, and then we need to subtract. Remember, when you subtract the total cost, you have to apply that negative to both the fixed cost and the variable cost. So minus the $10 variable cost per unit times our quantity. So here we have total revenue of 15 times Q minus 40,000 minus 10 times Q. That's the formula that we've created here. So at 1,000 units, machine A is losing money. All right, we need a formula for machine B. Machine B, again, total revenue. So in this case, it was $16 per unit, so 16 times the quantity. And now we need to subtract the total cost, which includes a 30,000 fixed cost, minus, remember that negative has to go to both of those costs, minus $12 per unit times the quantity. So it's total revenue minus total cost. Our total revenue here is 16 times the quantity, and then our total cost is that fixed and variable. So we subtract the 30,000 minus 12 times Q. All right, so if we then drag these down, then it will take those formulas and it will use those higher quantities. So now we can look at a couple of the things that we calculated by hand. So for example, we calculated by hand where the two, machine A and machine B, where they would have equal profitability. So notice at 10,000 units, the profit for machine A and machine B is the same, just like we calculated. Notice also that at 12,000 units, machine A gives profit of 20,000 and machine B of 18,000. Those are the same numbers we had calculated before. So we're just doing the same thing, but in Excel. The added benefit of doing it here in Excel is now we can highlight this information and we can insert a plot. So we can look at all of this on a graph. All right, so let's go and let's insert a graph. So you can insert a chart, or you can do it from the tabs. And so let's insert our chart here. We're going to do a scatter plot. We can have it give us some nice smooth lines here. And let's make this bigger so we can see it better. So what we see on the horizontal is the quantity. What you're seeing on the vertical is the profit. So notice that when we forecast the demand to be less than 5,000, then machine B is the more profitable option. It's still a negative, still a loss, but it's better than machine A. Notice that after you hit 8,000, machine A becomes profitable, right? We looked before at the break even. When we calculated our break even, we found that the break even for A was 8,000. You can see that here in the table. You can also see that here on the graph. And we found that machine B broke even at 7,500. Okay? Notice then that when you have higher forecasted demand, so if we're up at 2,000, 20,000, 25,000 units, machine A becomes the better option. So having a really good forecast makes a big difference because your capacity decisions are highly dependent on what you have forecasted for your demand. And then once you have your forecast demand, you have to analyze what is your current capacity and then how can we bridge that gap. Well, if there are different production methods or different machines or the possibility of outsourcing, then you start to look at this break-even analysis to see which method is more profitable. So how can we meet that capacity requirement and what will it cost us to do so?